Hello, and today I will show you what I did for my math project. So I will start by presenting all the criterias. For the first one, the point, I chose this point. It could be this one or this one or this one or whatever. I chose this point to be point A. For the second criteria, I chose this vector from there to be positive, and this vector from there to be negative. Third one is the same. For the fourth one, the null vector, so the values of the vector have to be 0, 0, 0. So I chose this point right here, right there. For the fifth one, so I chose z plus v. So this one is going to be z, and plus v is this one. So the resultant between those two is this one, this vector right there. So for the sixth criteria, I'll just skip it for now. So we'll go to 7. I chose the orthogonal projection, so it's like the airplane's fin behind. So right there, it does the orthogonal projection. So for the next criteria, which is the unit vector, I chose this vector from there to there, this direction, which is here the origin, and to there. So the values of this vector have to be equal. The magnitude of this vector has to be equal to 1. So this vector is 0, minus 1, 0. So the magnitude is actually equal to 1. So for the ninth criteria, the 3D orthogonal vector, I chose the airplane's wing. So right here to the plane actually, and I'll come back. I'm coming back to criteria number 6. So the dot product between t and s. So I'm calling this vector t and this vector s right there. And the dot product between those two, because they are orthogonal, so it means that the dot product between t and s are equal to 0. Now for the ninth criteria, which is not the ninth, the 10th. So the two-dimensional normal vector, I chose the trees that I did to the base, so which makes 90-degree angle. And the last one, the parallel vectors, which are on the base of the airplane. So this one with this one, or this one with this one, or this one or this one. So yeah, that's it. Thank you.